Students, welcome back. This video is for your practice set 5 to help you guys prepare for your upcoming exam. I will try to keep this video a little bit shorter. I know I've been hammering you guys with the videos, but I'm just trying to get through all the material in a seemingly orderly way, but I know you guys are still catching up on the videos and a lot of other work. So I'll try to make this video as clear as short as possible while still being clear. So let's just jump into it. Number 1, I have my Excel sheet here, and I'll post this Excel sheet as well. I'm gonna toggle between the Excel sheet and Spider, only so if I'm any code up, there's some code that I'm gonna do. I'll write the code in Spider, and I'll put the solution in Excel here for you guys. Actually, I'll have a separate Excel sheet just for you. I'll have a separate Python file along with the Excel sheet. So therefore, any of the code is written there. So let's start off with is classification. Let me save this. It's going to be spring 2020, and this is going to be PP5 answers. All right. Number 1 is classification supervised or unsupervised. Classification, right? Because of the fact that we actually have training data and test data that tells us, hey, this is right or this is wrong or this is 0, 1, 2, 3 or whatever it is, right? That is supervised learning, just like regression. So that is obviously supervised. Number 2, what is X in this situation? Okay, so here, guys, we have A, which is going to be an array from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11, right? So remember, it stops at 12. I'm using A range. And now here in B, I'm using that new reshape command I showed you. And this is saying, give me 4 rows of 3 columns, right? 4 rows of 3 columns. So literally this becomes, I think the easiest way to show you this is going to be B. And right over here, I'll show you what the 3 columns are. So 4 rows, 3 columns. Okay, so the first case, open it up with the extra bracket, right? The first row is going to be what? It's just going to be 0, 1, 2. All right. Nope. Close that up. Copy this. Okay, and then this is going to be 3, 4, 5. This is going to be then 6, 7, 8. And finally, this is going to be 9, 10, 11. All right, there you go. So B is going to be basically this, a double array. And finally, I say X equals B of 0 dot sum. Now, what's B of 0 going to be, guys? If there's no comma there, what's the first value before the comma? The rows. So B of 0 is going to be this array within the 2 by 2 array. And the sum of these values is going to be 3. So the answer is 3, right? Let me see if it's bigger. Hopefully everybody can see this. All right. Number 3. Make a green box that is 4 pixels high, 4 pixels wide, and place a red box in the center of it that is 2 pixels high and 2 pixels wide. Okay, cool. This is the fun stuff we just did with Tesla, right? Let me just slide over here into my NumPy array stuff. So, I mean, you can literally just go here. Let me save this as well. So, say spring 20. I'll say PP5 answers. I'll say PP5 underscore, just to differentiate this, Python, no, code answers. There we go, code answers. All right, and here I'll literally say this is in PP5 code answers.py, right? So anytime you see that, you know it's in the code, that the additional file. All right, so this number, make this bigger. Let's run this. All right, and literally, if you go to slide 9 in the code, it's right there. The answer is pretty much right there, right? So I want to make first a blue box that is 4 pixels high, 4 pixels wide, right? Just so you guys get an idea, it's going to be 4 by 4, 4 by 4, and then in the middle, 2 is going to be red, okay? The outer box is going to be green, the inner one is going to be red. All right, easy. So we start off with the fact that, I'll call this N3 for number 3. I'm starting off with, again, I'll start off with zeros, and I'm going to keep it easy on you guys. It's just going to be 2 dimensions instead of 3 dimensions, but I'm sure you guys can handle 3 dimensions as well. And p dot uint 8. Remember why uint 8? Because it's going to only be 0 to 55. Now, this reminds me, I need to go ahead and import my other pill, all right, to do this image, so you guys can see it as well. Now, I'll assume that you have this imported when you do your code. I'm just doing this so you guys can actually see it, visualize it. All right. Okay, and from here, you can go ahead and knock this out. Now, the outer box is going to be all green. Remember, RGB. RGB. Oh, sorry. I actually got a little ahead of myself. Let's do 4 by 4 by 4. All right. Boom. All right. Remember, this is a colored one. So it's going to be it's going to be an RGBA, because notice the 4 over here. If there was 3, it would just be an RGB image. So it's going to be RGBA image. All right. And I want, basically, there's a couple ways I could do this. I think the easiest way is to make everything green and then go in and make the inner box red. But you can do either way you want. So here, literally I'll say to make everything green, right? All the rows and all the columns are going to get 4 values, right? So the first one's red, we'll make that 0. The second one is green, 255, excellent. The last one is blue, the third one is blue, I'll make that 0. And I want it to be completely opaque, a completely solid color, I don't want any transparency. So the alpha, or the transparency, I'll make that 255, right? So here, I'll run this, and if you just want to check it out, how's it going to look like? I'm going to cheat a little bit. I'm going to use the matplotlib so you can just see it. And again, this part you really don't have to do during the exam. You don't have to do this part. I'm just doing it for your purpose, for your viewing, so you can see it. PLT. All right. Right, and now I'll basically take this array. I'm going to convert it into some sort of image. So I'll call this N3i for N3i image. I'm going to obviously use my image package from array function and just pass in the array N3. All right. So now this is an image, and now I can literally use PLT to show it off to you guys. PLT dot IMShow. And again, this part, the IMShow part, this is just me showing it to you guys. N3i and PLT.show. And I run this, and you see a nice little cute box here. See, 4 pixels up, 4 pixels wide. All right. Now, let me move this down a little bit. Okay. So I got the green box. So now what I want to do is just put the inner red box. And now this is where you probably have to put a little bit of effort into it, because I want it 2 by 2, and I want it in the center. Okay, 2 by 2, and I want it in the center. So already, what does this mean? This means that I have to, when I change the colors, right? Basically, the only colors I'm going to change is this. I'm going to make 0, and this, the red part, I'm going to make 255. All right, so let's do that. So let's talk it through. N3, right? N3. Which rows do I want? I want the second row and the third row. I want the second row and the third row. So literally I can just say 1, 2, 3. So it's selecting the second, the third, but not the fourth. All right, excellent. From here, which columns do I want? Well, again, I want the second column and the third column, right? But not the fourth. So excellent. I've selected now 2 by 2, the 2 by 2 pixels inside, or the 2 by 2 cubes inside my big square right here, you see. And now I'm simply going to take this value and just make the change I want. I want to change this to be 255, and this I'm going to make it 0. I run this, all right. I run that. I run this, and now look what you see here, guys. You have a green box with a red box in the middle. It's that easy. If I give you any arrangement of colors, if I always give you the breakdown of what the colors are, right? Like remember orange was a certain kind of color, a combination of these three. You guys can make any one of these simple images on the exam, all right? So here I'll save this, and that's number 3. All right, moving right along, number 4. All right, number 4, guys. I know you guys like this. You guys like these kind of questions. All right, what is X? All right, so A is an array of zeros. Five. So this is going to be literally 0, 1, 2, 3, 4. This is going to be A right here. But look at that look how sneaky I am over here, guys. You see that? How sneaky I am? It's a array. It's an array of zeros. Sorry, let me make this bigger. Where of type uint8. What are the values that can go in uint8? Only positive values from 0 to 55. Only positive integers from 0 to 55, right? So when I knock out this next line, basically the second and fourth position, make it 2.5 and 1.5, what's going to happen? In reality, right, it's now going to be, it'll take those integer numbers, but just like before, it's not going to take those decimal places. So the second value is now going to be 2. The third value, the fourth value is now going to be 1. And so now your A is going to look like that. And then when you take the summation of it, you're going to get the answer 3. You see that? That's the trick right there. If there's going to be a trick, that's the trick right there. All right, number 5. So number 5 is now, what is X? All right. Same thing as before, except we got a 3 by 3 by 2 dimension array. Okay, how do I show this? I'm going to show this in 3 boxes. So basically, you have a you have basically like this. You have a 0, 0, 0, 0. Close that box up. Open that box. You have another 0, 0, 0. This is the second row. Close that up. And now you have the third row right here. 0, 0, 0. Okay. This is the front. Notice you have a 2-dimensional object over here. You have a depth of 2. So this is the front of it, and this array right here is going to be the second one right behind it. So this is the front. This is the front. This is the one right behind it. Okay. And again, it's a 3 by 3. As you can see, it's a 3 by 3 multi-dimensional array with two dimensions. I mean, two depths. Now, what am I doing here? I'm saying take all the rows and all the columns. See, this is where it's probably better. I can put an enter. Can I put it? No, I can't put an enter in there. All right. I can. Let me. This is my only concern, that you guys are getting confused over here. Put that there. So it might be easier if I show you like this. All right. All right, so this is the front side. Right, this is the front one. And this is the back one, people. Front and back. Front and back one. All right. Now we come back here to number 5. So for all the rows, but only all the rows, but only the first and second columns. You see that? All the rows, first and second columns, make those values 2.5 and 1.5. Okay? All the rows, but just the first and second column. Now, notice how the 2.5 and 1.5, right? We don't select a depth over here, and we give 2 values here. The depth will be set to these 2 values, right? Because we're not selecting a depth, and we're giving the 2 values. So this automatically falls into the depths, automatically. So the front one, the first one is 2.5. So if I go here, this will be 2.5. This will be 2.5. But not the third column. 2.5, 2.5, but not the third column. 2.5, 2.5, but not the third column. I get here now, I got my second, it's the back one, the back 2x2 array now. And that is, ladies and gentlemen, 1.5. 1.5, 1.5, 1.5, 1.5, 1.5, 1.5, okay? And now I say x is going to be a of 0 dot sum. Okay, before we said when there's no commas, you say a of 0. What are you saying? You're saying the first row. What's the first row? This is the first row. But that first row, guys, has depth. What's that first row? Yeah, that is the first row in all the columns, no doubt. But that is also the front and back of the first row in all the columns. So it's going to be this and this. This and this. Okay? So that's going to give you a value of, that's right, it's going to give you the value of 2.5 plus 2.5 plus 1.5 plus 1.5. All right? Which is going to give you the answer, 5 plus 3, it's 8. Your answer is 8. All right, number 6. Number 6, what is x? All right, now here again, we have the same breakdown as before. Those are all zeros. 2.5, 2.5. So literally we can just copy this again. Keep that simple. Okay, first 2 lines are the same again. So we basically have this 3-dimensional NumPy array right here. And now I say, okay, x equals 0, again, the first row, comma, all the columns. All right, all the columns, swell, comma, 1. Ah, okay, okay. Now I'm selecting the first row, all the columns, yep, comma, 1. That comma 1 is actually now talking about the depth, so it's excluding the first one and going straight to the back one. So this answer now is just going to be the summation of 1.5 and 1.5, and your answer is 3. All right? Okay. Number 7. All right, what's number 7? Given the array A below, randomly divide its values into arrays B and C. All right. Given this array right here, right, this is going to be actually, sorry, it's a typo. This should be code. This should be code. All right, so I'll write down okay. Excellent. And from here, guys, what we're going to use, which function are we going to use to take the random numbers? Huh? Who remembers? Who remembers? That's right. np.randomPermutation. All right, so number 7, it's A and P, A range 10. All right, sounds good. So I think it's A equals NP dot A range 10. Yep, A range 10. All right, excellent. From here now, I wanted to subdivide these values in A. If I type it in right here, right, 0 to 9, I'm going to randomly subdivide them into two arrays, B and C. B and C. Okay, 5 in one, 5 in the other. So how do I do this? Multiple ways to do this. Obviously, the code I showed you guys in class is real easy. You can simply do AI for index equals np.random 5. Okay. And now this is, sorry, random dot permutation. There you go. All right. So actually, I'm sorry, not 5. We want it 10. S underscore I for shuffle indexes. All right, we're going to do 10. All right. And now, if you check out S underscore I here, guys, you will see that it's just random numbers. Those 9 numbers are now randomly, they're all over the place. And so what I'm going to do here now is I'm going to take the first set of those random numbers, the first 5, and put them into B. The second set, I'm going to put them into C. How do I do it? B equals A, bracket, S underscore I, 0, colon, 5. 0, 1, 2, 3, 4. The first 5 random values will now go into B, right? And for C, literally you can just copy and paste this. For C, it's going to be now 5, colon, 10. All right? Or just 5 colon if you wanted to. Right? And now I have the random values of B and C. All right? Boom. Easy. All right, number 8, using the above question, create an array D of true or false values, where the values in B and C are both less than 5 and make it false otherwise. All right, so this is the little trick. I'm testing whether you guys understood the trick of making another numpy array, having the values of one numpy array depend on the values of other numpy arrays. Okay, so here, this also number 8. All right, we have D using number 7. I'm now going to create something called the D, I believe it's a D array. The D array. And it's basically going to be true. It's going to be true or false. Basically, it's going to be true if both the values of B and C are less than 5, and it's going to be false otherwise. All right. So if you guys remember, D, right? Simply, if we just apply logic like this, if B is less than 5, right? This will create a Boolean for me. But in this case, I have two. In this case, I have two conditions. B is less than 5, and C is less than 5. Right? I go ahead, highlight this. I run it. Now let's check out D. You see B up there, you see C up there. You guys see it? It's kind of small. Let's do it for you. So this is my B. this is my C, and now this is my D. All right. Okay. 2 and 6. 2 is less than 5. 6 isn't. False. 4 and 1 are both less than 5. True. 7, 9, neither. 0, 8, 0 is, 8 isn't. 3 is, but 5 is not. False. So only 1 made the cut, right? So that's basically how we did it. Notice I didn't use a for loop. Vector logics. It's awesome. All right. Jumping to number 9. Sorry, I keep making this too small. I think this should be better. All right. 9. Given the training data A and the testing data B, do a twofold analysis on the training data for accuracy. Split it 50-50. What am I saying there? This is code as well. All right. What am I doing here? I'm saying, okay, when we randomly, when the cross-val, the k-fold cross-val analysis we did just for accuracy, right? We did it randomly. Obviously, you can use cross-val, but we did it, manually, so you guys could understand what's happening behind the scenes. This time I'm saying, okay, do it manually again, right? You have a training data A and testing data B. Do it manually again, but this time do 50% of the data, the training data of A, make it test data. Training data, and make the other 50% test, and go vice versa. Do the other side. All right. So this is just code. We don't really have these data sets, but this is literally, I believe, from this is from slides 21. I think 21, 22, 23. Right, and we already set it up pretty much beforehand, so we can do this again. It's number 9. Move this up. All right. So look, we have something that's B. This code won't run because there's nothing there. So I think I was A, B. Oh, training data A, testing data B. Okay, so A. So using my A quote unquote training data, right? I'm going to first take the random permutations of it. I'll call it shuffle. So shuffle will equal np.random permutation, and this is obviously going to be whatever the length of B is. I'm sorry, A. I keep the training data A. And hypothetically, when you do have the a NumPy array A, how do you get the let's see, do I have any example here? Yeah, excellent. I have an example here with N3. How do you get the dimensions? All right, if you type in N3 dot shapes, right, it literally gives you the dimensions of it, right? It's like it gives you back the values as a tuple, the dimensions of that in terms of size of the rows, the columns, and the depths, right? In this case, we just have training data that basically is just rows and columns, right? Rows and columns. I just want to know the size of the rows because I want to know how much to do the shuffling by. So here I will literally say A underscore R, using the tuple logic here, guys, equals B dot shape. All right, sorry, A dot shape. I keep doing that. All right, and this will give me two values: this number of rows and number of columns. I need the number of rows because I need to know what I need to know how many values am I going to randomly select so that I can break up the values from 50-50, right? The two sets. So here I will just stick in the A underscore R, right? And I will get the values for shuffle. And then I would create my subsets for A. So I'll literally call it A underscore 1 would equal A, again, A underscore R. And in this case, I don't really know like what's the, I really don't know what's my, I don't know the size of my A underscore R, and I don't know, obviously if I don't know the size of that, I don't know what 50% of that's going to be, right? So what I need to know is I basically need to know, okay, I'm going through, I want to go through the first half of AR underscore, the first set of values in AR, like we did up here. This is what we did up here. But I don't know what number to go up to, right? I really don't know what number to go up to. So that's easy. I mean, there's a function I'll show you called int, and basically you can get the midpoint, I'll call it m for midpoint, of the rows, of the rows right there. Now let's say it's an odd number of rows. There's a function called int, right? There's a function called int, and that basically will give you the midpoint right there, right? That'll give you the midpoint right here. And from here, I can literally go 0 to m is going to be my first subset, right? And my second subset is going to be, just copy and paste this, m onward, right? Whatever that might be, And so now I have my two subsets, A1, A2, and from here I can do the training that I wanted to do, right? I can do the training. I assume we have an SGD classifier, right? Assume we have an SGD classifier. We don't even have to stack them up on top of each other like we did for the lab because it's only 50-50. Nevertheless, just remember how to do that. And here I can just go ahead and do my fit, right? I do my fit. Assume you already have the classifier defined as SGD. And literally you'll do SGD.fit, right? A1 underscore 1, and the test will be A underscore 2, right? And your predict and everything else pretty much falls into place from there. Your predict score will be basically your, oh, I'm sorry, I forgot to do the test data. Sorry, we forgot to get the test data. Hold on. Sorry about this. B is my test data, so B underscore 1 is going to be same thing except for the B values. B, right, that's fine. And this one will be B2. This is my test data. Apologize there. Excellent. All right, so now I can fit my model. All right, A1, B underscore 1. All right, so now I have the model fitted, and now I can go ahead and test it. I'm going to test it predicting it now, right? So the predict one is going to be basically SGD dot predict A2, right? That's my test data. I mean, that's my my test training data, right? And from here now I want to basically figure out the accuracy like I did before. Remember we did n correct, I'll call it underscore C, equals sum predict 1 equals what? The test data for 2, all right? And here, if I simply do n underscore C divided by length of predict 1, I have my accuracy for the first one, when the set 2 is the test data, and we could flip it for my next one. We could flip it where the first set is the test data, right? I'm sorry, I don't need all this. I just need this right here. So now I'll do A of 2, B of 2 will train the model. I'm going to predict now. I'll call this predict 2. This is going to predict A of 1, and C will now be predict 2 equals B of 1, length of B of 2. All right. Same thing like we did last time, but this time we just did it for a shuffle of 2 instead of a shuffle of 3. And same thing, if I asked for you a shuffle of 10, you know how to break it down. It would be a lot more work, but you guys know how to break it down. All right, so that's number 9. Number 10, all right. Now we're having some fun here. what is the precision of the confusion matrix below? Okay, now remember, what is the definition of precision? The precision is basically saying out of the ones that were selected to be a certain, to be true positives, right? That were predicted to be a certain class, what percentage of them were actually that class, right? Now, in a 3x3 or n by n by matrix in this situation, it's literally going to be the summation of all, if we go back to the original formula, like formally it's basically true positives divided by whatever is predicted of a certain class. Now here, I didn't ask you what's the precision of A or B or C. I asked you what's the precision. I'm not being specifying a particular class. I'm saying, listen, give me the precision of the whole confusion matrix, right? The precision of the whole confusion matrix. And the way you would basically calculate this is you would take all your true positives, which are diagonals right here, right? All your true positives, and you would divide that by all of your predicted values, all of your predicted values at this point, right? So in this case, what would be the precision of this matrix, right? What would be the precision of this matrix at this point? Well, it's going to be, so for all of it, it's going to be basically the diagonal here, 5 plus 6 plus 4. That gives me 15. And divided by all the other values, observed values. 5, 3 plus 1. This is 10 plus 8, 9 plus, so 9 plus 6 is 15. 15 plus, I'm sorry, that's actually 9 too. So 9 plus 9 plus 6. So that gives us a value of 24. 9 plus 18, 18 plus 6 is 24. That's going to be 24. And the actual answer is going to be 0.625. All right, that's precision for the whole confusion matrix. Now, it's more precise. It's more precise when I finally ask for, hey, give me the precision for, let's say, B. So precision for B basically would be the predicted B, which is 6. I'm sorry, the true positive B, which is basically right here, 6, divided by the predicted B, which is 9. So that would literally be 6 divided by 9. That gives you 1/3, basically 33% or something like that, along those lines. Okay? I'm sorry, 67%. It'd be 6 divided by 9. 6 divided by 9, which would give you like 67%, something along those lines. All right? So that's the difference between the whole matrix and a particular class. Now, number 11, right, is basically the confusion matrix again, but this time I'm saying, okay, what is the recall of the confusion matrix below? What is the recall of the confusion matrix below? All right, now guys, what's the definition of recall, right? Recall is basically given a certain class you're searching for, right? Given a certain class you're searching for, what's the percentage of that divided by the number of the actual values, right? The actual values. So the true positives divided by the actual values of that actual class. So this is going to come out to be the same thing. Why? Because we're doing it for the whole matrix, right? The true positives again, 5 plus 6 plus 4, right? 15. And again, we're going to divide it by the row sums. The row sums are going to equal 24 too. 6 plus 9 plus 9, right? 6 plus 9 plus 9. That's going to give me 24. It's going to give me the same answer all over again. That's what happens when you do it for the whole confusion matrix, right? But whereas last time, I think we did it for B, we did the recall, I'm sorry, the precision. God, I can't type for some reason. We did the precision for B, which gave us like a 67%. What's the recall of B, right? What's the recall of B? Well, what's the true positive of B again? It's 6, right? And this time, it's 6, it's the true positive divided by the actual b. So this would be 6 divided by 10. So whereas the precision was 6 divided by 9, the recall is going to be 6 divided by 10. All right, and so it gives me a recall of 60%. So in the individual elements, classes, precision recall is obviously going to be different. When you do it overall for the matrix, it ends up being the same. And for 12, it finally gives you a more suitable problem. For number 12, what is the false positive ratio of B, given the confusion matrix below? Now again, what is the definition of false positive rate? It's the false positives divided by the actual no's. All right, it's the false positives, the ones that are predicted. By false positive, we mean it was predicted to be a certain class, but it's in actuality it's not. So in this case, for cases I said for B over here, okay, here the column is a prediction, right? This is predicted to be B, in actuality is A, that's a false positive. And this is predicted to be B, but this is actually C, that's a false positive, right? Over here is the only true positive. You want to take all your false positives and you want to divide them by your actual no's, right? So in this case, what's my actual no's, or what's my actual non-B's? What's the summation of my actual non-B's? So our numerator is easy. 2 plus 1 is 3. Those are our false positives, right? What's your denominator? Again, the false positive is for the ones that are actually no. How many times does it in this case, predict B? How many ones are actually, so for the ones that are actually A and C, how many times is it actually predicted to be B? How many ones are actually A? 5 plus 2 plus 1 is 8. 1 plus 1 plus 4 is 6, 14. So this becomes 3 divided by 14. Oop, I don't like that. 3, let me just put, is 3 divided by 14, right? In actuality, the answer is going to be, for B at least, the FPR, false positive rate, 0.21. All right, 0.21. Obviously, FPR, we want that to be low as possible. All right, 13. Back to more familiar territory. I have A. Ooh, this is nice. A range is 0 to 10. I think I have this from before. I'm going to go ahead and cheat and grab it right here. Excellent. All right, I'm going to go ahead and dump that last value. What is happening here? Okay. Sorry, Excel. It's hard to see my Excel sometimes. All right. Okay, so now I'm doing -1, -3. Now, look, it's A range 10. So A range 10 is going to be not 9. It's going to be up to 10. I'm sorry, not up to 10. It's going to be up to 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, that's number 1. But when I do x equals A -1, -3, what is that? Remember what negative does? Negative goes the opposite direction. But unlike our zero-based index, negative starts with 1. Negative starts with 1. So -1 means, if I simplify this, it basically is going to mean, okay, give me 9 and -3, which is 7. 9 and 7, the summation of that is going to give me the value 16. It's that easy. Number 14, we're almost there, guys. All right, assume you use the SGD classifier to do a classification. You have the following variables. Excellent. Targets B, class scores CS, precision P, recall R. Now, what do we want to do? We want to write the code, this is code now, to select the thresholds that give you a prediction with 90% recall. With 90% recall. All right, this is where we messed around and we said, all right, we want to get a certain caliber or value of thresholds, and then from there, so I think here, I just want to select the threshold, right, where my predictions will be with the 90% recall. All right, so this, again, I don't have to go over there and do it, but let's keep it consistent. All right, so precision P, recall R. Precision P, recall R, and thresholds. Oh, thresholds. Okay, I think we're missing thresholds over here. You need thresholds. So assume threshold is threshold. All right. Assume the variable. So the threshold part is actually the main part here. So we're missing that. So assume threshold is threshold. Okay. All right. So here, this is number 14. All right. Now, if you remember, last time we did for precisions, we wanted to do greater than or equal to 90%, right? For recall, right? For recall, we also want to do it at a value, because remember, your threshold was the x-axis, right? When we were graphing those two graphs together. So that's how you would do it visually, but mathematically, we want a recall that is greater than or equal to 90%. So here, I'm going to choose threshold. We'll call it T underscore 90. That's going to be thresholds. And again, this won't work if you try to run it because these variables don't exist. Where recall now, guys, R, I have the variable R. R is, remember this, okay? Remember, recall and precision always have one extra value than threshold, right? Is greater than and equal to 90%. All right, now, threshold is an array of thresholds. This is going to be multiple values. When we did this for precision, we got the minimum one. But if you're looking at the graph, right, if you look at the graph, if you were to choose the minimum threshold that gave me a recall of, sorry, this should be 0.9, of 90%, right, of 90%, then what's going to end up happening here is I'm going to get a, I mean, for precision, we did minimum threshold. So that because the thresholds, they all go from 0 to, like, I think in our notes it was like 10,000 or 1 million, right? But as you go out further and further, your recall is going to drop. So you want the threshold that gets you to, well, and I'm sorry, we wanted the precision in our notes that got us to 90% for the smallest threshold possible, the smallest threshold possible. All right. Now, because after 0 it goes negative, recall goes up negative, right? Again, I can get the 90% values, anything greater than or equal to 90%. And it'll give me a bunch of thresholds. Each one's more negative than the other. Each one's both negative than the other. But remember the way negatives work. A -5, right? A -5 is less than -2. A -5 is less than -2. If I were to say, hey, give me the threshold with the smallest threshold, it's going to give me a negative number. It's going to be the largest negative number. And those largest negative numbers, yes, they do have obviously they're going to have high recall, but then they give you low precision. Again, look at slide 48 in the notes, and visually you can see what I'm talking about. So in this case, we're not going to say min. We're going to say, listen, give me max. Give me max. All right, give me the maximum out of these set of thresholds where the corresponding threshold gave me a recall that was 90% or greater. Give me the maximum threshold, because it's going to be a negative number, right? And that maximum threshold will now give you the smallest negative number Therefore, you stay as close as possible to 0. And so that's how I identify my threshold in number 14. That's how I identify the threshold that gives me the prediction with 90% recall. All right? Slightly bigger, smaller. All right. Here now I have some theoretical questions. This should be easy for you guys. Easy. All right. Your classifier is being trained to identify five different classes. All right. Using SGD classifier, how many OVA classifiers will be run? That's easy. OVA stands for one versus all, right? So it's going to be a binary classifier for each class. Class A versus not class A, class B versus not class B, etc., etc. The answer is 5. And also, fun fact, for SGD classifier, as you guys remember, that is the default. OVA is the default. For number 16, if your classifier is being trained to identify, again, the same thing, how many OVO classifiers will you have? Who remembered? Okay, now OVO is 1 versus 1. Who remembers the formula for how many we'll have, right? Who remembers the formula for how much we'll have? It was what? It was your number of classes times your number minus 1 of classes, divide that numerator by 2, right? Okay, so in our case, if we have 5 classifiers, 5 times 4 is 20. 20 divided by 2 is 10. In this case, I will have 10 classifiers. All right, 10 classifiers, 1 versus 1. Number 17. Your classifier is being trained to identify 5 different classes. Okay, same thing again. Using random forest classifier, how many OVO classifiers will be run? All right, guys, how many will be run? As I pause with a deceptive look in my face. The answer is none. There will be none OVOs, and also there would be none OVAs, because random forest classifier classifies. That's what it does. It doesn't do 1 versus 1 or 1 versus all. It's one of those few classifiers, right? It's one of the few classifiers that don't do 1 versus all or 1 versus 1. It straight up does its own thing called classification, all right? This is a trick question. The answer is none. All right, I'm so sneaky. Number 18, given the array 3, 1, 6, 5, 2, scale the numbers using standardization. All right, I'm going to cheat here a little bit. If you guys remember, standardization was what? Standardization was basically your z-scores, right? Your z-scores. So I have the values 3, 1, 6, 5, 2. And so first I need to get the average. Oops, stop. Stop it. That's the average. I'm going to subtract them by the average. I'm going to max, so I can't really do the dollar thingy. Alrighty. And now I'm going to divide these bad boys by, I'm sure there's an Excel formula for this. I'm just doing it this way just for dramatic effect. Oh, they actually have a standardized function. Look at that. Standard deviation. Let's do standard deviation. We'll do it for, technically we should do it for sample, but it really doesn't matter in this case, right? Just do straight up standard deviation. So I'll use population. I'm cheating here, but you guys don't cheat. You guys remember what the standard, how you get standard deviation, right? Right? I'm looking at you guys. Right, so here now I divide by standard deviation. and boom. All right, and now these are my new values right here, right? It's basically the z-scores. You take the z-scores. And number 19 is basically going to be the same thing, except now I'm using normalization. Now, do you guys remember how we do normalization? First we divide by the, I'm sorry, we don't divide. First we subtract by the min value. This is actually a lot cleaner. What's the minimum value here, guys? It is 1. So I'm going to subtract all these values by 1. Okay? And then what do? We divide by the max minus min. What is the max minus min here, guys? It's 6 minus 1, which is 5. So I'm going to divide all these guys by 5. All right? And as you'll see, it scales the value between 1 and 0. All right? It scales the value between 1 and 0. Remember, you want to use standardization when you have outliers, and min-max can be used when the numbers are more closer to one another. All right, finally, the last question, guys. Convert the confusion matrix below into, this is code again. So I'll jump back into dot. All right, and here, let's do number 20. So basically, we're going to convert the confusion matrix below into percentages, what each actual was classified at, according to what each actual value was classified at. So we did this also in our second set of slides, right? We wanted to do it so we have more nuanced analysis of our data visually, analytically, using the colors, right? So this is going to be relatively easy. Let's assume this matrix name is CNF, right? So CNF, I'm going to start off by doing the row sums. Who remembers what the trick for row sums was, guys? That's right. We're using the, I'll call it RS for row sums. CNF dot sum axis equals 1. And we want to keep the dimensions. Remember, axis does it according to the rows, right? Versus it's taking the summation of the whole matrix. And keep dims, right? What that does is it keeps it as a 2 by 2 array so that when I go back and I do create a new percentage-based CNF, it's now I can do CNF divided by RS, and I literally will divide every row by its each row summation, right? Just like I think in slide 15 in our second set, lab part 2. And there we are done, right? It's that simple. We are done. And it looks like I came in under an hour. Okay, I'm at an hour, I think. Whatever, it's an hour. I talked a little bit fast, but give you guys a little bit of break here. All right, so you guys can spend a little extra time reviewing the material. And I'll talk to you guys later to go over this video. All right, bye-bye.